Zeenath Jaha Begum from Department of Computer Science Engineering from the college MLR Institute of Technology. Today, I'm going to discuss about the algebraic law of regular expressions. So in the last class, we discussed about the finite automata, and that we discussed about the DFA as well as the NFA. Also, we discussed about the conversion of NFA to DFA, as well as we discussed about the conversion of finite NFA with epsilon to NFA without epsilon. So we are going to discuss about the regular expression. So in that, what are the different algebraic law of regular expressions are there, we are going to see. This is very simple as well as very important topic in the finite automata. So coming to the algebraic law of regular expressions, here we have some 6 to 7 laws. So coming to the first law, that is nothing but associative law. So here associative law, what is the use of the associative law and how it is going to be defined? So whenever we write the laws will be defined with the help of the operators. So if you can see here, the first associative law, that is A plus B plus C can be written as A plus B plus C. Or if you are using the dot operator, it can also be written as A dot B dot C, which is equal to A dot B dot C. So that is nothing but that is the associative law. So if we write in terms of the numbers, we can say like this: 3 plus 4 plus 5, which is equal to 3 plus 4 plus 5. Both the answers will be same. In the same way, if we do in the multiplication, that will be 3 dot 4 dot 5 is equal to 3 dot 4 dot 5. Both the answer will be same. So this is the first law of associative, and which we are using in the regular expression. Now coming to the second law. Second law is a commutative law. So how commutative law it is going to be defined with the help of the plus operator as well as with the help of the dot operator. So now coming to the plus operator, that is nothing but here we can say that A plus B is equal to B plus A, or A dot B is equal to B dot A. That means if we give 4 plus 5, which is equivalent to 5 plus 4, as well as if we give 4 dot 5, which is equivalent to 5 dot 4. That is nothing but reversing the numbers will be equivalent to the result. That is nothing but that is the commutative law. Now coming to the identity law. So identity law is nothing but 5. 5 means nothing. So nothing plus A, which is equivalent to A plus nothing, is nothing but A. Or we can also write as epsilon dot A. Epsilon is nothing but where we have a no transition between the one state to other state, we are using the epsilon symbol. So for that, if epsilon dot A is equal to A dot epsilon is equal to A. So these laws are very important when we solve the problems on the regular expression. Next, coming to the annihilator regular expression, that is annihilator law. So what is the use of the annihilator law? What is the law for that? That is nothing but we can simply say that phi dot A is equal to A dot phi is equal to phi itself only. This is what we can say that it is the next version of the identity law. Now, and coming to the fifth law, that is the distributive law. So distributive law is nothing but here you can see here we have left distributive as well as the right distributive. So now coming to the left distributive, you can clearly see here what is that A dot B plus C is equal to here. In the distributive law, we are multiplying here. That means A is multiplied with B plus A is multiplied with C. So simply what the answer it will be A dot B plus A dot C. Now coming to the right distributive, that is the reverse of the left distributive, that we can say as B plus C dot A. That means it clearly can be written as B dot A plus C dot A. Next law, idempotent. Idempotent is nothing but if we write A plus A or B plus B or C plus C, the result here it will be the same whatever here we are writing. For example, here we are writing B plus B, that is equivalent to B only. C plus C, it is equivalent to C only. So whenever we add the same numbers, the result will be also same. The next one, closure law. So closure law is defined with the star symbol. So actually, when we discuss about like union operators, intersection as well as the closure property. So whenever we say about the closure, so closure is simply defined with the star. Star means it has a possibility with a zero or more than one transition. So whenever we say here the closure law of regular expression, it has to define with the asterisk. So here you can see that clearly a power star whole power star is equal to a power star, or 5 power star if nothing is there. Simply here we can write what? Epsilon. In the same way, epsilon power star is equal to, it will be epsilon. That means nothing. If you just overall, if you do it, if you do one time, two times, so on, n time, the answer will be what? Epsilon itself. In the same way, if it is a power plus, it can be written as a into a power asterisk, which is equal to again a star a, and also a power star can be written as a power plus plus epsilon. This is what this is the closure property. Now coming to the last law, that is a De Morgan's law. So De Morgan's law is nothing but here we are writing plus converting into a dot. That means if we have a plus b whole power star, so that can be written as a star b star, that is whole power star. That is nothing but that is the De Morgan's law. So these are the laws which we have seen in the regular expression. So before doing the problems on the regular expressions, here we have to discuss about the laws. So some of the laws here we have discussed in the today's session, that is, first is the associative law, then commutative law, identity law, annihilator law, distributive law, closure property, as well as the De Morgan's law. So in the next session, we are going to discuss about some of the problems on the regular expression, as well as we are going to see about the convergence of finite automata into the regular expression. Thank you so much.